Alright, another draft physics, draft science here on YouTube. Video presentation. So Robert Ritchie, he's made a couple of videos doubling down on his over unity, free energy, antimatter machine thing. So, so we'll have to play some of that just because it's. But the whole thing is kind of tragic in the sense of a description of how brains can go totally wrong. He's way too old not to have learned some lessons in life about jumping to conclusions, and it's dangerous. I mean, it took a while for me to learn it too. I mean, I said some things early on 10 years ago that I was wrong about, and it's an unpleasant sensation. And besides that, it hurts your credibility and all that kind of thing. You just can't do this crying wolf thing. So you got to be sure and certain, and before you make statements and declarations and blah blah blah. So lately I've been more reliable. Let's just say more careful. But it's the whole conspiracy theory thing. All these people with all these silly notions, and just based on tiny shreds of evidence, and it's just it's what they want to believe. They want to believe somehow there was 8 million or more illegal votes in the election, and blah, 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 and they don't really prove anything. They just say, well, there's shenanigans, everywhere. So it must be there too. Some kind of vague bullshit. And people live for this stuff because it validates some underlying wish or hope. And maybe that's what all this comes down to. Religion and the fact that human beings just can't separate themselves from silly optimism because they think it's the only way to get through the mush is to sell this fake story about the fake wonder or our fake adventure in our fake. It's all fake. It's all bullshit. It's probably not relevant, but I'll just bring it up. I saw the sequel to the Prometheus movie, the aliens thing. And it's just amazingly poor formula for a movie. I mean, they were surprised it didn't do that well. Well, because it's just so dismal. I mean, I'm a dismal person, but I mean, they take away all things to root for. So there's just absolutely nothing to give a shit about. And then they kill everything. I mean, basically. And you're just like, what did I watch that for? Just too stupid. I mean, and they film it in dark vision, and it's just, what the hell, what are people thinking? Anyway, I mean, to give you nothing to root for is just too stupid. There has to be something in a movie where you're saying, I'm picking that side. There has to be something. You just can't, you just can't have it be, oh, well, that turned out as badly as it possibly could. That was fun. So obviously we all, even me, the Dark Lord, I mean, even Darth Vader probably didn't, jerk off to, cats getting run over on the street or something. I mean, you gotta have something to, perk you up a little. But anyway, so making that excuse, obviously I'm saying they've taken that inch and gone all kinds of miles in the wrong direction. Anyway, so back to the physics. Sorry, I really wish not to do anything superfluous on this channel, but I'm human, and we do superfluous things. So I'll place this crap, but it's just such crap, and it's so stupid, and its claims are so idiotic. DraftScience corrected, so he's not going to correct a damn thing I said. And then he says actual proof that DraftScience is wrong. And there's no proof here. There's no experiment. There's no demonstration of the reality. Nothing like a proof. So it's just like, even in all his time on Earth, he hasn't figured out what the word proof means. Where you actually have to provide a little bit more than nothing. Ugh.
you spend money on Lego crapola, billions and billions of dollars. I'm just asking you to put up a little bit for the trouble.
I ain't putting up.
I'll commission the experiment to be done.
Hey, but
no need. I got the proof.
No need. I got the proof. Well, then why don't you collect the money? Why don't you make the bet? Okay, so he's, this is a clip of me just pointing out, well, let's do the experiment, So instead of saying, yeah, that's a great idea, let's do the experiment, and we'll have the losers finance it, essentially. I mean, that's what I'm basically saying. I'm saying I'll finance having the experiment done well, and I'll collect the money from you losers, because you're going to lose. Yeah, so, yeah, win-win. Except for you lose.
Machined things, nicely done. It's going to be really kind of simple, okay? It's just going to be things rolling, and then they're going to hit a spring, or they're going to hit a lever, and they're going to exchange their energy.
Blah, blah,
see
blah.
What they exchange.
So he says blah, blah, blah to the idea of that's how the best way to measure something's energy is to have the energy hit, where they're opposing each other. That would be the ideal, so you could actually see that, there's no shenanigans. That you didn't have different conditions or different this or different that. You're just measuring Thor against Midas or something. You're just measuring the power of the gods by having them bang into each other.
And there won't be any noise, and there won't be any sounds, and there won't be any of this bullshit for you to say half the energy disappeared in some bizarre way. All right, we'll agree on the experiment. You'll tell me you're predicting a certain result. You say something has twice as much energy as this thing. We're going to drop the two things, so to speak, on a real spring, and we're going to see if they have twice as much energy, okay? So fuck you in this bullshit. I'm asking you, let's do the experiment. Unless you have the experiment already done somewhere. So if you just link
It's already been done?
It's already been done, so he's not going to show us anything being done. I mean, that would be the simple point right there where you're saying, okay, I say, all right, show me. He says it's already been done. Link me to it already being done. I'd be very happy to see it. We'll be done with this argument. So show me, okay, where you measured the actual energy something had, okay, by some standard that would be rational, right? That we could agree is actually measuring its energy.
Many times.
You got these 400 or 500 joules of energy out.
Oh, yeah, we'll prove it. I will show you.
So he's talking over my video again. So people can't get even the simple basics right. That you pause somebody if you need to talk. You don't talk over them. If I talked over your video doing this video, you'd find that kind of obnoxious because you'd be saying something important. I'd be totally ignoring it by talking over it. So you can't even get these basic rules of civility right.
Thing is moot, okay, and you win.
I do win.
You can't provide any evidence.
But I can.
You bastard.
Yep.
You piece of shit. Anyway.
There's no evidence in here. Like this is just hilarious that he thinks I've proven it with my evidence. He didn't prove anything.
Oh, Gary. Right. Your own video shows this. It takes 4 times the energy to move a mass 4 times the distance.
No, it doesn't. It depends on the circumstance, of course. So that's sort of agreeable. Energy in, energy out. But again, this whole distance argument, they're saying distance is the only thing that tells you how much energy something has, is how much distance it travels. When the whole point is that, no, it depends on the force, and it depends on what you're using as something to take the force away, the opposing force. So we'll get into that. I mean, the more important one is the second statement.
Any rational person would agree with that.
Whatever.
And your own video shows that it takes quadruple the energy to double the velocity.
So that's, where I'll disagree. Doesn't take 4 times the energy.
Right? So we've got these bits of paper where we've been doing the math. And we can prove that something 4 times the height has 4 times the energy.
Okay, it doesn't have 4 times the energy. It's only going to gain twice as much velocity. So let's understand it's only gaining twice as much velocity, and it surely doesn't have 4 times the energy, in my opinion. Not even, there's no reason to believe that it has 4 times the energy. So it really took, you could argue it took twice as much energy to get it to that location, but it didn't take 4 times as much energy because it's only going to have twice the velocity when it hits the ground. So same mass. So this is just an argument. I said this before, I'll say it again. I mean, you can't say that gravity is F. Okay, now that was what Newton was talking about. He was talking about all this stuff happening in gravity, and he wrote these formulas, and so everybody thinks these formulas apply to everything on Earth. they don't apply to everything on Earth. Every force is different. If I use magnetism, I'll get exactly the inverse kind of reaction, in the sense that magnetism gets stronger as you get closer, to opposing charges. And so if I throw a magnet into a repulsive field, all right, I'm going to get the exact opposite result. I'm going to get less and less and less distance, and I'm not going to be able to speed my way out of it or any of this other stuff, unless I get to, luminal speeds. I'm not going to be able to game the force. Okay, so it's a different force. So if I'm using a magnet, or I'm using gravity, or I'm using this, or I'm using that, all the forces apply the force differently. And so the simple mental analogy I can give you is, if you see weightlifters and they jerk weight, okay, so we're back to this argument about momentum being a real thing. And the fact is that you would say, okay, it takes a certain amount of energy to lift 10 pounds a certain height. Well, it doesn't take a certain amount of energy. If I do it really slowly, you can understand that if I lift the 10 pounds really, really slowly, it'll add up to a lot more energy. So if I had a machine to lift it and only lifted it a centimeter at a time, it would use up a lot more energy to lift than if it just, lifted it quickly. And that is, it has to use energy to hold it. It can't just lock it into a position. It has to constantly apply energy against gravity through the whole process. You could understand that, oh yeah, it's going to use up a lot of energy. I'm just saying it can't just put it up on a stair and then put it up on a stair and then put it up on a stair. It has to lift against it all the time. So the same thing you can understand with a weightlifter, right? If the weightlifters had to lift the weight very slowly, okay, over their head, you'd understand that, they're going to use a lot more energy. They're not even going to be able to do it in the first place. And besides that, they're going to use an insane amount of more energy. More calories are going to be burnt. More muscles are going to be torn apart. They're going to be destroyed by the process. But if they jerk the weight up, if they get it out of the rain as quickly as possible, the rain of gravity, they have to use less energy. And that's the fact. So again, the argument is you have to understand what gravity is. It's a force, okay? And it's a force that has certain rules. And those rules aren't the same rules for every other force, explosions and cannons and all these other things. It's not the same force. It doesn't cause the same effects in the same way. So, that's where all this physics goes wrong, is apparently physics never recognizes that all forces aren't equal. Okay, that they're all a little different. They cause effects differently. So I give you the simple analogy of, I can give you bullets, I can give you anything you want. Okay, let's say I have a gun that shoots bullets, and it's shooting them at a rate. All right. Yes, I still haven't replaced that. So the gun's shooting bullets at a certain rate. You can understand, or light even. I mean, light gives it away, right? You can understand. So there's a light shining, okay, and I'm going from point A to point B. All right. You know that the faster I go from point A to point B, right? Let's say this is in the shade and this is in the shade. All right. The faster I go from point A to point B, you've got to understand that, well, I'm going to get hit by less light. Less light is actually going to hit me. The faster I go, there's going to be less photons. Total photons will be less. So the faster I can go, the less total energy will hit me, right? And so you could argue the same thing with bullets. You could say if I was shooting bullets and I ran into the field of bullets, I mean, it sounds unintuitive, right? But if I ran into the bullets, you can understand that if I got from point A to point B fast, okay, the total number of bullets, if we count the bullets, 1, 2, 7, 20, we count how many bullets hit you, the quicker I get to point B, the less bullets hit me, right? So if there's bullets in the field, we know, so there's 6 bullets, let's say, in the field. So if I go as the speed of the bullets, you know that the least I can get hit by is 6. That'll be all I'll get hit by. And the slower I go, the more bullets are going to hit me. So you can understand if I took 10 minutes to do this, there would be 6,478,974 bullets that actually hit me. That's how much force, that's how much energy, okay, I will be collecting. and I'll end up going that way, right? Because all that energy is going to hit me. But you can understand that, right? So this isn't that complicated. I really shouldn't have to make these arguments that gravity has certain rules that don't apply to everything. There's not the same rules for everything. And you can understand why it takes more energy. So if you understand gravity as being a convergence, an anti-divergence, as Susskind would say, okay, you can think of it as ether. I don't care what you think of it as, but it's stuff. Okay, it's stuff. Okay, it's moving stuff. It's saying bent space stuff. It's whatever you want to call it. It doesn't matter, but it's real stuff, and it falls at a rate. Okay, it hits things at a rate. It's coming like rain. It's falling. So if you're in the rain, okay, and you're basically a bucket. You're gonna collect a certain amount of rain based on your mass. And the simple rules are: if I have a smaller mass, it's a smaller bucket. And all we're really doing is saying, okay, if I give you, I give you spring points, a certain number of spring points, okay, so I'm giving you 18 units. I don't know why I keep using 18, but it's probably some reason. Okay, so I give them both the same number of units of potential, of energy, of joules. You could sort of understand that the small bucket, okay, isn't going to collect the energy as quickly as the other bucket. And so as they go up, they're right at this point. You can say at 1 second there's a certain amount of rain that was in the field, and the big bucket is going to have, let's say it collected 18. You can figure out that the bucket, half the size, well, it only collected 9. Right, so it's got more work to do still. It still has its momentum because this thing lost it, okay? I mean, it collected more in the same amount of time. Now, you also know that this is moving faster because I gave them 18 units. The units are in the fact that this is moving faster. So, because it's a smaller bucket, it's moving faster. So, you also know that in that time where it collected the 9, because it's a smaller bucket, right, it also moved twice as far. So in the time that this one moved, the 1 unit of distance, this one moved 2 units of distance, and it collected less, right? Now, it collected a little more because it's moving into the rain, but let's understand that the rain's moving the speed of light, so the difference will be irrelevant. It's such a tiny difference in total volume of force actually hitting you. But you're getting hit by force coming up the other way too. So, so negate that as an important factor. And you can understand that, okay, now it's twice the height already, just because it has the extra velocity. And because it's half the size, it's also got that other half. So obviously it's going to go 4 times because it's twice as small and it's moving twice as fast. So it's going through the rain twice as fast. So it's going to collect the same amount, but in twice the distance. It's going to have traveled twice the distance. And then we just do the rest of the equation. You end up 4 times higher. Now, if I lift a weight into gravity, so we'll just to make the final point that I made with the weightlifter thing, you can understand that, okay, I take 2 things that are the same size, okay, and I'm going to lift them into gravity. Now, we know that when they, to fall at twice the velocity, I have to go 4 times higher. So what's the trick when, we're just going to double the velocity. So this one has twice the velocity, but they have the same mass, right? So this one's twice the velocity. So you can see the scenario, right? That now the buckets are the same size, all right? And I'm going to come back down with twice the velocity. So the buckets, well, I should draw them the same size. So they're going to collect it the same, but this one's going to, because it has the highest velocity now, it's going to be traveling at that higher velocity, so it's going to go twice the distance in that first unit of time. At least twice. So I have to think about that, because its velocity is the peak here, and then its velocity will decline with distance, so it's going to be more than half. So it's going to travel more than half the distance in that first 1 second. versus the other object, because it's going to collect. That's how fast it's going. So by the time it has done 1 second, it's going to be here, where this one's going to be stuck back here in 1 second. And so that's the trick of it, right? So it's just about how much you collect. How much you collect is decided by your mass, and how big, and the mass tells you how big the bucket is. All right, so what I wanted to get to was the simple weightlifter argument. So you can understand that if I just took two items, and so this is going to give them velocity, and let's just say that you lifted one very quickly to a height, and you lifted the other one very slowly to that height. All right. So this one took 5 seconds, and this one took 1 second. You can understand that they have the same size bucket. They're going to get to this point in 1 second, and there's only so much rain that fell in 1 second. So you know that they're collecting the same opposing energy per second, but this one's in it for 5 seconds. So you know that by sitting in the rain longer, by just being in the rain longer, it's collecting every second. It's collecting whatever, 10 things of rain, 10 molecules of water, or whatever, however we want to look at it. By the time the 5 seconds is up, yeah, it's collected 50. And so I could slow it down even more, and I'd make it 500. So just depending on how fast I move into the gravity will dictate how much energy I have to use to oppose the gravity. The longer I'm in it, the more I'm going to have collect rain. The longer you stand in the rain, the more wet you get, because gravity is a continuous force. Okay, it's not a volume of force, it's not a quantity of force, it's a rate of force. So there's a big difference between comparing things that have momentum and they have one amount of joules of energy worth of momentum, right? And they don't give it away in a rate, they give it away as a quantity. They give it to another object. All right, so there's no rate involved. There's no how long were you in it, how much of it were you exposed to. So that's why gravity fools you, because the fact is, the faster you lift something, the less force you have to apply to get it to a certain height. So it takes less energy. That's the trick. If you have the velocity works to your advantage and gets you through the force much quicker and easier. You collect less of it. The faster you go, the less gravity you collect. So therefore, you use less energy. So speed means less energy and gravity. The faster I lift something, the less it actually weighed, so to speak. I'm making it lighter by moving it quickly. It's just a fact. And it'll take less energy to get to the same position the faster I move it. So the faster I move it, the less energy it takes. That's the truth. That's momentum. Because I start with momentum. I start with an advantage of velocity. Yeah, so that should be understandable. I mean, as it just being a fact that if I move it slowly in gravity, I have to use more energy. And the quicker I can move it, the less energy I'll use. And I can't eliminate the gravity, so there's always a certain, if the fastest I can move it is 1 second, well, then I'm going to have 1 second worth of gravity. I'm going to collect 1 second worth, and that'll be the minimum amount of energy I have to use. And I can't do any better than that. But the fact is that I can use less energy by getting it to the location quickly. Just a fact. Distance isn't a reflection of energy. It's a reflection of how quickly you moved it. It really should be enough. Should be understandable. Just go back to the weightlifter and just understand that if I told the weightlifter to lift it up slowly, you have to realize that the gravity keeps pushing all that time, and that he's opposing more and more force the longer he takes to get it from point A to point B. The longer he takes, the more gravity he's going to collect. The more disproportional rate of force. How else to say it? It's like a conveyor belt or something. A conveyor belt's dropping stuff at a rate. You understand, the longer you hold your bucket under it, the more you'll collect. You know, duh. All right.
And the equation, 1/2 mv squared. Now this if you do 1/2.
So he thinks this is a proof. And again, it proves nothing. I can make those numbers dumber and dumber by just changing the velocity
Of the mass at 1 kilogram, and the final velocity, it's only 4.905 meters, but the final velocity is 9.81 meters a second. So 1/2 of that times the 1 kilogram mass times 9.81 squared equals this answer right here.
Yeah, and again, nobody disagrees that you have to lift it 4 times as high. I already did videos on that saying, yeah, that's the way it works. You want to go twice the speed, you have to go 4 times higher in the gravity, because the fact is the gravity takes time to accelerate you. And in the first second, it doesn't accelerate you the proper distance. You only go half the distance you should have gone if you were actually moving the speed of the gravity. But you're not moving the speed of the gravity.
48.11805 joules. Now, I double checked these calculations, they are 100% correct.
They're absolutely meaningless. You didn't measure anything. You didn't do an actual experiment. And again, you're doing the same experiment in gravity, which means it doesn't mean anything. Distance in gravity doesn't mean anything, because it's how fast you move in the gravity that matters. The faster you move through the gravity, the faster I move past a light bulb, the less photons that hit me. It's just a fact.
If you move the object to 4 times the height, now the first one is 4.905 meters, and the second one is 4 times the height, which is 19.62 meters, right? You agree on that? And here's the formula. This is for gravitational potential energy. You multiply.
Right. Again, so again, you're doing a gravity formula when we've. The fact is that as I'm pointing out, gravity, you use less energy the faster you go. It has a bias for velocity. The faster you can move into gravity, the more distance you can travel. Just a fact. Because you will be collecting less of it because it's coming at you at a rate.
By the mass times the gravity times your height, and you end up with this number here, 48.11805. Now,
if you walk into the machine gun, you'll collect more bullets. If you run into the machine gun, you'll collect less bullets. Fact.
Now, if you take it up 4 times the height, you end up with exactly 4 times the energy. Now, I did this on my handheld calculator.
I mean, this idiotic notion that I somehow am doubting the numbers, when that's just idiotic, and I'm overtly telling you, you can't have the same momentum. 2 objects can't have the same momentum and have different amounts of energy. So again, I could go right back to the physics girl video and just tell you, explain that. How do you completely convert the momentum? So 100% of the momentum is transferred. All right, you can't go from 10 miles to 5 miles an hour, with half the weight if you didn't convey all of the momentum. That is, every single bit of the energy had to successfully be transferred for you to be going 5 miles an hour. You should be going 4 or 3 if you lost any energy. So 100% of the momentum is transferred, yet they claim they lost half the kinetic energy. That's ludicrous and stupid. So that's the first thing I wish you to concede, is that argument is nonsense. Then you can sit there and tell me that all forces are gravity, and I'll argue, no, they're not.
I also used an online calculator. All the figures agree. So we go back to the original sheet here. It takes 4 times the energy.
So let's understand, when 2 steel balls hit each other, there's no rate of force. Okay, there's no time thing that's relevant. How long the 2 balls are stuck together, that doesn't make any difference. It's a complete transfer of the energy. There's a certain amount in one of motion, and now it's going to be transferred into the other one efficiently and completely. And there's no rate. There's no rate of anything. There's just bucket spills the energy into the other bucket.
Energy to move a mass 4 times the distance. And also we say To double the velocity, it takes quadruple the energy. And that's simply just dropping a...
So again, it doesn't take quadruple the energy. It can take 1,000,000 times the energy if I lift the ball slowly. So if I take my time and lift it really, really slowly, I can use, you know, 1,000,000. I mean, I can use a nuclear power plant's worth of energy to lift something if I lift it very, very slowly. You know, slowly in the sense I'm constantly holding it against gravity. I don't put it on a, you know, I don't put it on my skeleton. You know, I don't use my bone structure to hold it up. I'm using actual muscles to hold it in position. So if I'm using my muscles to hold it in a position, I lift it slowly, you can understand that you will use a lot more calories than if you just lift it quickly.
1 kilogram mass. You can do this in any comparison. As long as the ratio of heights is 1 to 4, you will always get a 1 to 4 outcome, and that is 1/2 of m energy is equal to 1/2 of mv squared. And there.
So again, it's just gravity is fooling you, and every spring will have its own relationship. So you know, I could say that, you know, I can use a spring constant. I can tell you, okay, there's a spring. Well, as the spring compresses, you don't go like, it's not in perfect segments. Like, okay, if I do all the way compressed is a unit of energy, and then if I do half the compression, that's 1/2 the amount of energy. No, it gets progressively stiffer as you go in. So frankly, if you want to double the velocity, you don't push the spring all the way back twice as much. You just push it back a quarter amount more, and then it gets to be an 1/8, and then it gets to be a 1/16. Will give you twice the energy back. So I mean, every kind of force storage, you know, and I guess gravity in a sense is a storage device. Magnetism, springs, gravity, they all have different coefficients. They all apply they all store the energy differently. And they have different, there's different things that'll give you advantage or disadvantage based on whether you have velocity or whether you have mass.
Is your proof. Undeniable proof.
Okay, so it's completely deniable proof that you have in any way proven that it takes more energy, okay, factually, takes more energy to lift something 4 times as high. Because if I lift it twice as fast, it won't take 4 times the energy. So if my lifting speed is twice the velocity, it will not take 4 times as much energy, it'll only take twice the energy. Simple fact. That's the real fact. You're wrong, and you're stupid, and you're obnoxious, and you're arrogant, and I would all add insane and loopy and crazy, but you know, what's the point? Because they don't do anything about people being those things anymore.
So stop trying to mislead people with your sophistry and your false physics, which is undeniably wrong.
Okay, it's completely deniably wrong. I think I've given enough examples where any local pumpkin-brained noob, science noob, could even understand, you know, running into bullets, you know, running past a light bulb. I think even an idiot could understand that, yeah, the faster I go past, you know, there's 2 walls, and I'm going to go from the shade to the shade, and I want to get hit by as little light as possible because the light's going to burn me. The quicker I go, the less light will hit me. Yeah, that's the way it works.
Right? I don't have to call your names. All I've got to do is prove you wrong, which I've done here. There's the math. There's the experiment.
Sorry, doesn't prove nothing. Sorry, you lose. Yeah, so far from a proof, it's not seeing any light.
I've done this experiment in college. I remember it well.
Yeah, so what? I mean, you know, again, the experiment isn't showing you real energy. As I just stated, the slower I move the object up to that point, the more energy it'll take me to do it. The faster I move it to that point, the less energy it'll take me to do it. That's a fact. The faster you go into gravity, the further you're going to get into gravity. Gravity has a bias for velocity because it's falling at a rate. You collect less if you're in it less. You collect less if you're in it less. There you go.
Well, there is your proof. So just drop that little error that you propagating out there to the masses, and just realise that energy, kinetic energy, is equal to 1/2 of mv squared.
No, it isn't. It's a silly, girly, silly nonsense formula. The whole history proves that it's nonsense. It was never right. It was always just loop-de-doo, almost conspiracy theory origins. The man who stole, who's accused and was pretty much proven to have stolen, Newton's calculus. He's the origin of this nonsense. A petty, resentful loser. Okay, that's all. That's the truth here. It's garbage physics, naysayer, nitpicker physics. It's troll physics.
Don't worry about elastic or inelastic or delayed time transitions. That's the formula. 100% correct.
It's 100% nonsense. It's never correct. It's never giving you the real energy. The real energy is momentum. Momentum is the only thing that exists in the universe as a measure of energy, is movement. Period, 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 period. And yes, if you move into rain, okay, the rules change a little.
Okay, little tiny video. I just couldn't take it anymore. I saw you criticising everyone, calling people names and carrying on like you're some guru, which you're obviously not.
Yeah, I have no interest in being a guru. I don't tell you the truth. I explain the truth. All right. I draw the pictures of the truth, and I show the videos of the experiments. So you show the experiment where they used 4 times the energy to put an object into a gravitational circumstance. Lifting. You lift it at what speed? Because the truth is, the faster you lift it, the less energy you're going to use. Just a truth, a fact. A fact.
There's your proof on your physics of motion. Read it and weep.
No, you weep, you eat crow, fucker. Okay, Yeah. So you lose. You've humiliated yourself once again. So this is what he does. He puts that ha-ha in there and says, oh yeah, I'm the guy with integrity. Yeah, no you're not. Okay, so let's play his other loop-de-doo video. I was really, didn't know whether I would bother wasting my time, right? Because he's demonstrating here that he's just plain crazy. Okay, so what's the point? Except to say, gee, this is really disappointing that, there's all these crazy people, that you end up collecting whenever you create an anti, a force against something established. There's always all these followers who are just made out of resentment, they want revenge, they want, all these negative, they're not doing it because they seek to make things right. They just seek to destroy. They seek to do the sledgehammer thing. They don't want to fix something. They just want to break things.
And there's your output. So you get a low energy input, you get a very high energy output. It's way above unity.
Okay, so it's way above unity. So what he's saying is he's invented a machine, so his own little accelerator or something, and he's smashing actual positrons. I don't know where he gets them from. There's no such thing, okay, so, but whatever, okay, let's just pretend. I mean, even that whole positronic blah, 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 these medical devices, they're not making positrons and shooting positrons into you. They just speculate that when they shoot the actual radiation into you, okay, the X-rays, that what's actually happening is your body is producing positrons, and those positrons are making these collisions that cause photons. They just made that part up. So there's no actual positrons that you get to see, or that they're actually mechanically doing something. There's no such thing. Well, anyway, so he's saying he's made a little collider, and he can collide positrons into electrons, and he can cause them to create neutrinos, blah, blah, blah. Now, he asks, well, I think it's in here, so I'll wait till then. But anyway, so he says he's creating gamma rays with 1,000,000 times it's 1,000 times the energy of the electron and positron that went in. So they have 1,000 volts going in, and he gets 1,000,000 volts coming out. Well, it's 1,000 volts coming in, but anyway, the point is he's saying he's getting 1,000 times the energy of the electron and proton, or somehow creating gamma rays that have 1,000 times the energy of the initial electron and positron, which is just absolute nonsense. Again, it's all about momentum. All they have is momentum, and they're going to release their momentum. You could argue that if I had I had a proton and I had an electron, and I did throw them at each other, that they could spin around each other and actually create some gamma rays. But they're not going to be able to keep doing that because they don't have perpetual motion, and they're going to lose energy, and they're not going to create 1,000 times more energy. They can only create so much movement. That's it. And that much movement's going to be 1,000 volts or less. It's going to be some lesser number than what you actually put in. You can't get out more than you put in.
And if we could make because this is gamma radiation.
He's not breaking an atom. See, when you break an atom, you have lots of energy left over. He's not breaking an atom, so he has no place to get the extra energy. He can only get it from the electron and the positron. And they just can't make 1,000,000 volts. They can't do it.
It's very, very dangerous. You need probably about 1 meter of shielding.
So you need 1 meter of shielding, a lead, right? 1 meter of lead to stop his super gamma blah blah blah. I don't even know. I mean, I frankly don't know how far through a piece of lead you can get a gamma ray to go. So, I mean, the volume doesn't make any difference. So how many gamma rays you create doesn't make a difference. So why would these gamma rays need so much more lead than the gamma rays from space or some other place? And all I need is a little bit of lead and I'm fine. Why are these special gamma rays? Because again, volume doesn't make them go through things better. So making more gamma rays doesn't mean you need thicker. It's the fact is the gamma ray has a certain penetrating power, and that's what it has.
Just 1 meter thick in all directions. So the device is going to be at least 2.5, 2.6 meters in diameter, and that.
So this might be on some false notion that he thinks he's made a super gamma ray. Like the gamma ray frequency is so small, so tight. It's an infinite thing. I mean, theoretically, you can try to make these gamma rays as small as you want. And if you make them smaller and smaller, you're supposed to make the frequency higher and higher. That somehow you've made something more, that you're creating more and more energy by increasing frequency. But yeah, I'd argue that we have no evidence that you can do that. I would argue that the limit is, the fact is that there is a Planck constant, and you can't go beyond the Planck constant. And I think that's seen by black body radiation. There is no, you can't get to any of these super energy photons.
Size, you're probably looking at several megawatts output. But anyway, I thought I'd do the whiteboard presentation, so you've got a picture there to reference. You hear me talking about it and trying to explain it in the simplest terms.
So he's doing all this bullshit. So he says he has some stupid machine that does some stupid thing. He hasn't demonstrated anything to give us any indication it means anything. And then he's giving us theory that, how the fuck do you know? You're just putting, obviously you can have a machine and you plug it into the wall and electricity goes into it and certain things happen. But this is all bullshit. I mean, this doesn't mean anything. How did you prove that this is what's happening in your machine? Even if your machine is producing gamma rays, how do you know this is how it's producing them?
Now, one conundrum we generate here is, if an electron is a fundamental particle, we've got two fundamental particles that are supposed to annihilate and produce nothing but energy.
Well, that one over there is a positron, so I don't know, you think positrons really are elemental and fundamental, even though, where are they? Where are they hiding? Where are all the positrons hiding? Where have all the positrons been hiding? I don't see them anywhere. They don't fit in any model of the atom. Where could they be?
And my question is, where do these neutrinos come from?
Well, exactly. The only reason why the neutrinos exist is because when real physicists do the math for this crap, they come up with a little leftover energy. See, their gamma rays aren't super powerful gamma rays, and so they don't create enough energy. So they say, well, there must be something else leaving because there's still a little energy left over. So let's call that neutrino. So a couple of neutrinos pop out, and then they can complete their little mathematical formula. But that's the reason why neutrinos don't exist for any other reason than to say, where do we put our extra little bits left over after we did our math? And so they called the extra bits that's left over when they do their math, they called it neutrino.
If an electron is a fundamental particle, where do the neutrinos come from in the collision? Now, with my crude apparatus,
I just explained.
I cannot detect these neutrinos, but this is what physicists are telling me that happens in the mutual annihilation process.
Yes, because they're not getting a million extra free volts, or they would have told everybody that. See, if the real physicists could figure out how they could get this extra million volts to pop out when they just crash two of these little things into each other, then they'd be like, oh yeah, a million neutrinos came out, or they'd come up with some other theory. But they couldn't get this 1,000 times the energy back thing. They can't get these little electrons and positrons to give them that extra 1,000 times the energy in. They can't make that happen.
I know, and I can prove I'm generating these gamma photons because they go through, well, I had half-inch lead plates, it's about 12.5 millimeters. The radiation went straight through those, and I'll write it down here.
Right, so it's some sort of super gamma ray, right? So it's more powerful than the normal gamma rays that regular physics creates, because regular physics doesn't need to do all that crap, as it doesn't create any of these super gamma rays. So he's creating a gamma ray that should be called something else. We should call it a Ritchie ray, okay? Because nobody else has made one.
The beam from here was a 5-degree divergence. Right? 5-degree divergence on the beam.
Right, so he's creating a beam, so he must have some focal point for which he's shooting at, that he's creating this thing from. I don't know what the fuck his emitter looks like, but he's conceding it's coming out like a laser beam. You know, it's spreading with distance.
We're looking at a very, very narrow beam.
It's actually not that narrow. 5 degrees is pretty big, actually.
Now, I told some people about this, and I told them not to try it at home. They didn't have the necessary equipment. I know they tried it at home because I think they're dead now.
Okay, so he thinks they're dead now. So this is the first. See, he's always storytelling. So he gave this technology to somebody. He won't mention who. They irradiated themselves and died. But there's no newspaper articles about how a couple of guys were found dead with a nuclear reactor in their living room. No. So there's no facts here at all. Nothing to indicate that this is anything like a true story. But he's basically saying, yes, I killed a couple of fellas, because I gave the technology away. So story number 1, who believes it? Well, not me.
This is lethal radiation, what we're talking here. If you expose yourself to this, you will get sick, you will die.
Yes, you got to be a little careful if you're going to play with stuff. But so I imagine this all has to be done in some sort of vacuum, because nobody could create these kind of effects in atmosphere. So I don't know what his device is, but again, he's arguing that this is going to get us to Mars, okay, creating this gamma bomb, whatever it is. I mean, it's so lethal that he has to have a meter of lead shielding. So let's understand, he's going to take his machine that has 1 meter of lead shielding, right? That doesn't weigh much. Lead? Yeah, lead isn't heavy, right? So it has a meter of lead shielding around it, and he's going to get that off the ground, okay? Because he's getting all this extra energy. He's going to put a Duracell battery in it and get 1,000 Duracell batteries out, right? But he still has to move a big giant fucking ball of lead. Yeah, lead wrecking ball. He's going to shoot a lead wrecking ball to Mars. Sure you are. Sure you are. Good luck with that.
Okay, now I did a lot of this from a distance, standing away from the beams, off to an angle. These beams...
I think some of the radiation did do some damage. I'm sorry, but I think so.
Ionised fluorescent tubes through lead plates, half-inch lead plates. So this is
Yes. That's everything's always proven by the old fluorescent tube trick. You know, like that isn't so old by now.
very dangerous energy. I don't want you to try it. I just want you to look at what I've.
I'm not even sure if that works, frankly. You know, gamma rays. I don't know if gamma rays actually do create enough of a charge differential on the tiny prongs on a fluorescent tube. So I don't even know if gamma rays will light up a tube.
Presenting here, and I'll write it here, so there's no. This is anti-matter.
Well, it actually isn't, right? I mean, if we're going to use the word antimatter, that really should be something that has, you know, an anti-nucleon. You know, that the nucleus is actually negative and the orbiting bits are positive. That would be antimatter. So I don't know what the hell, yeah, frankly. I mean, that should be the rule of the word anyway.
Now we can do the same with atoms, but I'm not allowed to show you how.
I'm not allowed to show you how. So here's story number 2. So story number 2 is the government came to him and told him he's not allowed to tell us. He can tell us this part, but he can't tell us he can do the same thing with atoms. So he apparently knows how to make an anti-atom of some kind, and he's going to throw it at a regular atom, and annihilate them and make even more energy. But he's not allowed to talk about it because the government came to his house and told him he's not allowed to talk about it. Now, let's see. What's the believability of that story? -4. I mean, it's less than 0 believable, right? Yeah.
To show you that I'm not allowed to, I can basically make the statement, but I can't divulge any of the technical information, and that's due to representatives of the government visiting me a few years ago and
Liar, 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 pants on fire. Okay, so all the people who have had the government come to their house and tell them they can't talk about something, just send it to me. Send the information to me and I will publish it. Okay, I'll publish anything. So send me all the reality you have proof of, that the government's threatened to put you in prison if you release this information. Send it to me, I'll release it. Now, anything short of how to make a nuclear bomb, okay? So, I mean, obviously I'm not going to publish that, okay? But, and that's already known information, okay? So you show me the special technology that physics doesn't know, okay? And the government's secretly controlling it or something, and you're not allowed to tell the public about the special technology. Send it to me, I'll publish it. And I'll collect no money for it, ever. I'll promise never to exploit your brilliant idea. I'll just publish it.
telling me what I could and couldn't tell you. So read my body language.
Kook, crazy, fart, nutball. Yeah, I got it nailed pretty well.
I'm 100% A1 on this.
No, you're 100% in need of a straitjacket and some quiet time.
I don't want to go to jail, all right?
I don't want to go to jail. So just a horse shit. You know, that's just, isn't that the same bullshit we've heard 4 million times? So just conspiracy theory nutter, you know.
So this is antimatter, simplified antimatter interaction, neutral annihilation, and we'll go.
So anyway, this, whatever that even means, it annihilates how? You know, what does that even mean? So you turned electrons and positrons into photons somehow? Could you prove it? Yeah, no.
Do some more math on this and show you exactly what I mean. Now, this is probably the most efficient way to generate energy.
Except for the 1 meter of lead plate you need, it's real efficient. Yeah, sure. Except for that 1 meter of lead plate.
It's way more efficient than fossil fuels. It's almost hazard-free if it's treated with the right safety constraint.
Except for the 1 meter of lead plate you need around it.
It's harmless. I'd like to see facilities built underground so there's no chance of this stuff leaking out into the environment. What else?
Yeah, and it can only blow up if it blows up. Anyway. What the fuck?
Yeah, that stuff we can have here now. I could build you one today. I could build you one in a matter of hours. I've got all the gear here. I only have to put it together and...
So isn't that all we always hear? That's exactly what we always. Everybody's got the Tesla technology, and all they need is a few dollars. Just send me some tubes of glue, and I'll glue it together, and it's going to work. How many times have we heard that bullshit?
Yeah. So that's my little presentation on electron mutual annihilation. Argue against it if you want. You're welcome to.
Yes, it's not electrons, by the way. You just said it's a positron, so at least call the thing what the fuck it is, all right? It's not electron mutual annihilation. It's some sort of positron-y thing. You have a little red arrow, little plus, E plus. Get it right.
I don't care. Put your arguments up and...
What is there to argue? There's nothing to argue. You've shown nothing. This is bullshit, wacky theory in the first place. I doubt the existence of neutrinos. I doubt the existence of positrons. The whole thing is just bullshit, and I doubt the existence of your super gammas, your mega gamma.
I'll give my point of view and see how we go. But, yeah, that's the sort of stuff I'm into.
Whatever. Alright, just loop-de-doo, crazy poo. Yeah, so speaking of loop-de-doo and poo, Stephen Bro. Okay, so this is, there's still some argument going on the Professor Lewin stupid thing where he said there's two voltages in one place, and I obviously said too silly. Any location has to have, the same voltage. You can't have different pressures inside of a tire, for example. It's the same pressure everywhere. Okay, so I just thought some of this, it's just so funny how these people are so obsessed. And look at all this crap he writes, and he says absolutely nothing. He's just rambling on, telling a story. I like your logical step-by-step breakdown of the problem and the solution as you see it. So there is no breakdown of anything, right? The probe wires are conductors being put into the experiment. So as I pointed out, the same argument solves the Faraday paradox, okay, where with the spinning disk and the magnets and all that stuff, and the simple explanation is to tap the coil, you have to put a wire into the a magnetic field, and by putting it into the magnetic field, it's going to induce a current in the wire. So you can't read the voltage with a wire that's in the magnetic field that's already got a voltage in it. Okay, and that voltage is going to change what you're going to read, so you can't read the voltage. Anyway, and I look forward to one day finding time to check your other work here. I'm just very pushed for time, working on too many projects at once, so I had better not return to this one until I've cleared some space to think properly. Yeah, like that'll ever happen. The funny thing is Steven's channel now is just, it's just these crank videos, where he's quote mining me, saying he proved something. It's just all horse shit or nonsense. So he makes two kinds of videos: absolute nonsense or horse shit. Ugh. But anyway. But very briefly, I remember having difficulty accepting Walter Lewin's claim 3 years ago, a bit before it became popular topic. Yeah, it only became a popular topic when Electric Boom did it, but I did even before then, because when I played Professor Lewin's whole series of videos, obviously that video where he's doing this experiment came up, and I said right at the time, bullshit. You can't have two voltages at the same location. It's bullshit. Alright, courtesy of Electric Boom. And then I supported, Electric Boom was doing the brave thing and arguing that the old man is full of shit. And then he pussied out. So after the old man said, I'm sorry, you're as dumb as a flat earther, Electric Boom said, oh, well, he apologized to me, so it's okay. He said he was sorry. I'm dumb as a flat earther. Anyway, doing this usual trick of comparing. Okay, the popular topic, courtesy of Electric Boom, closely followed by. So again, no, that's not the history. Again, liar. Okay, the history is I pointed out how it's nonsense long before Electric Boom did the video. So that's just nonsense. And then Electric Boom provided a much more detailed explanation than mine. Doing his usual trick of comparing it to something far too simple and irrelevant. So car tire. So he's saying pressure isn't relevant, and the fact that you can't have different pressures in the exact same location in space. So for me to argue that nobody would think you could have two different pressures inside the same location in space, and obviously no one should think there could be two different voltages in the same place in a wire. Okay. To be of real value in comprehending Walter Lewin's understanding of the problem. Well, clearly Walter Lewin didn't even want to try to understand the problem. And it's so obvious that you have to count the probe wires once they're in a field. So if you're going to put the probe wires in a field, a magnetic field, you have to know that they're going to be affected by that, especially a changing magnetic field. Gary, DraftScience, claimed it was tantamount to claiming we can have two different pressures within one tire. Yes, which is a perfectly rational argument. But his understanding of electrical principles leaves a lot to be desired. Well, yours is even less desirable, I would argue. So anyway, so it's difficult to have a rational conversation with him. Well, I don't know where the difficulty comes in. But anyway, not only on this, but anything. Well, blah, blah to you. I think he could invent new science just for about anything. So, where do we get that from? I clearly have, my agenda is clear, okay? I think the elemental functions are simpler, not more complicated, and I've provided a simpler theory of mechanical function for the universe, which I don't mind a little bit. But, but in his case, it's like returning to a 1,000-piece jigsaw puzzle. So again, no, it's much simpler, not more complicated. 2 + 2 + 2 physics, lot simpler. That was almost complete, only to find Gary had completely redone it by chopping bits off and hammering them and or gluing them with chewing gum. So all this is based on absolutely no rational connection to anything I'm actually saying or actually asserting. And the whole thing noticed me smaller and unrecognizable as an actual picture. So that's just too silly. I've given you a simple diagram for how the two-slit experiment works, a simple diagram for how gravity works, and a simple diagram for how momentum works, and how a simple diagram for, what's the other one? There's some other one. All right, having said that, Holiday, so we're going back to why did it bother me that Holiday turned into a complete idiot? Okay, anyway. Having said that, Holiday asked Walter Lewin directly on my behalf, so now he says it's on his behalf, as Holiday himself had no answers to this one. So apparently Holiday didn't want to ask him either. So he's that's really kind of slimy. He's saying that Holiday wouldn't have asked Professor Lewin on his own. He only asked him because Steve asked him to. Why wouldn't Steve go directly to Walter Lewin and ask him himself? That doesn't make any sense. But Walter Lewin gave him short shift. Yeah, exactly. Basically, look, he gave everybody short shift, so everybody got the same answer from him, which is you're a flat earther. Okay, he didn't counter argue any of the points made. Basically said go and Google it. Yeah, he basically says he doesn't want to even engage in a conversation about probing experiments and whether in some cases you really can't do it. You can't get an accurate reading because your probes are being corrupted by being in the experiment. So I myself asked Walter Lewin, and he told me almost the same thing, only adding, I can't help you any farther. Well, at the time, I figured he had helped me at all. He hadn't helped me at all. All I asked was for a simple drawing of the layout. Well, that everybody already had, so why don't you just watch his demonstration? You need a drawing of something he demonstrates in a video? I mean, you can see how he's probing the experiment. A meter's on the left side, a meter's on the right side. The two probe wires go in, and we know that the magnetic field has a right-hand rule bias, so obviously one side, the probe wires are correcting a positive current, and on the other side, they're creating a negative voltage. All right, anyway. At the time, I was thinking along the lines of electric boom that the location of the meter probes were possibly the factor. So yeah, I think it's clearly the right answer. I don't think it needs to go any further than that. How could each meter be assigned to measure the voltage across one or the other resistors? Again, it's not a matter of even touching the experiment. The probe wires are the experiment. They're a whole new experiment you're doing, okay? So as soon as you move the probe wires, you don't even have to touch anything. And the probe wires are already collecting voltages. All right, so I don't need to go any further. This is just blah, 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 and he comes to no conclusion. So anyway, this is on some nut jobs video. So this John Walker guy's a kook, and then that's connected to another kook, that's connected to another kook. They're just, it's just a whole bunch of these, kooks. It's just a little collection of kooks, And it's sad, they only got 9 subscribers and all that kind of stuff. So I mean, they should, be able to get more of a hearing. But they should also be told that they're kooks, in gentle ways. People should gently let them know that you're really crazy, it's time to go, find some pills or find something to counteract the fact that your brain is way, 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 way off the staircase. You're floating, way off the track. Alright, anyway, enough of a video. So, till the next time and such, and so forth and whatnot. Yeah. Well, I can do it this way. Alright. Hey, what happened to me? I stuck back here. That's not proper. All this time. Anyway, till the next time and such. You don't need to see me, really. Just amazing. This planet is amazing. I almost wanted to make a video about how we are living in a matrix, because it's sort of proven that nothing could be this ludicrous, right? I mean, the story is getting so silly that it's almost like, this can't be reality because it's too flawed. I mean, it's too improbably stupid. I mean, Trump being president was really weird. I mean, physicists who can't do shit. They can't do grammar school physics right. They can't even understand that, gravity is a continuous force. And, I mean, it's too stupid. Yeah, it's just too ludicrous. It can't be reality. It's got to be some drunk, some pothead computer coder who made up this stupid story. Anyway, not actually a serious theory. Just making a joke. Humans are fish, so now it makes sense. Oh, they're fish. That's why they're dumb as shit. Yeah. Oh, okay. Till the next time and such. This has been a DraftScience video presentation.